Kia ora, year 11 and 12. This video is one that goes over a couple of good basic things, and one is the sum of random variables yet again, and one is some revision of Poisson, including the conditions. But it's also good for level 3 stats, so I'm making it with both my classes in mind. If you're watching this and you're doing level 3 stats and not A level, some of the things I do in here we'll do slightly differently, but I'm going to try and address both classes during the video. Okay, so the first question is one where we've got the weights of bags of fuel and we've got a mean of 3.2 and we've got a standard deviation. And we're trying to find the distribution if we have 3 bags of fuel, and that's denoted by T. All we have to do is the mean and the standard deviation of T. We don't have to find a probability with it. So Scott, if you're watching this, this is part of the question you sent me today from level 3 stats, which is what's the difference between the sum of random variables and linear combinations. So this is going to give you part of that answer. The second question is just really good practice at Poisson. So we've got a number of goals scored by Everly Rovers per match, and it's got a mean of 8. We have to say when we can model that with a Poisson distribution and then find a straightforward Poisson probability. And then we've got a combination question in the last bit. The manager promises the team a bonus if they get at least 1 goal in each of the next 10 matches, and then we have to find the probability that they win the bonus. So I'm going to whip through those reasonably quickly. I'm going to talk a bit about graphics calculators. A-level people, you'll just have to put up with that for a couple of minutes while I do it. Okay, so we've got a bag of, what is it? A bag of fuel, and the bag of fuel has an average weight of 3.2 kilograms, and it's got a standard deviation of 0.04. So whenever I'm working with kind of expectation algebra, I don't want to be working with the standard deviation. I want to move back up to the variance. So that's going to be 0.04 squared, which is 0.0016. Now T is the sum of 3 of those bags. So I've got 3 things with variation. So my expected weight is going to be this. It's going to be E of x1 plus E of x2 plus E of x3, which is just 3 times 3.2, which gives me 9.6. For the variance, I'm going to do the same thing. The variance of T is going to be the variance of x1 plus the variance of x2 plus the variance of x3. And since they all have the same variance, that works out to be 3 times 0.0016, which gives me 0.0048. But I don't want the variance, I want the standard deviation, so I take the square root of that, which gives us 0.0693 to 3 significant figures. So just notice the important thing in that question is that I don't work directly with the standard deviation, I work with the variance. Okay, and it's not a linear combination, right? It's one where I've got 3 bags. So each bag has variation, and I'm adding up those variances. Right, on to the second part. So we have to say 2 conditions for x to be modelled by a Poisson distribution. We looked at these in class today, but one more time. The easiest one to start with is that we must assume that we've got a constant rate of goals being scored. And you could argue about whether that was actually realistic or not. So no matter who they're playing, where they are in the season, if they're playing at home or away, we've got a mean rate of lambda is equal to 1.8. And the second thing to say is that goals occur randomly. Or we could say that goals occur independently of each other, but they're the two that I would say there. Now we have to find a probability. So we've got to find the probability that x is between 2 and 6, but not touching the ends. So that's equal to the probability that x is equal to 3, 4, or 5. So here's when I'm going to split the video up into 2 halves. If you're doing this and you're doing 314, you're going to grab your graphics calculator. You're going to go to PCD, right? The C stands for cumulative, and that's going to give me the probability that x is less than or equal to 5. But if we think about what we don't want all of that, right? So we want 5, 4, or 3, but we don't want that. So we have to subtract off the probability that x is less than or equal to 2. So we'll go PCD with 5, write that number down, and then we'll go take away PCD with 2. But if we're doing that using the formula here, what we're going to get is e to the negative lambda times lambda, so it'll be this, right? So this is for A-level students, the usual thing. So that's working with the formula. So just be careful with that. Or you could use the recursion thing that we've done, but this is probably the fastest way, and that gives us 0.259, and I've rounded that to 3 significant figures. So let's look back at the last bit, which is worth 3 marks. The manager promises the team a bonus if they score at least 1 goal in each of the next 10 matches. So this is quite an easy kind of compound problem, because I just have to find the probability of at least 1 goal, and then I'm going to take that number and put it to the power of 10. Okay, so the probability of at least 1 goal is equal to 1 minus the probability of no goals, which is 1 minus e to the negative 1.8, which gives us 0.834701. So don't round that one, because we're going to use it in another calculation. So the probability of at least 1 in all the next 10 games, or in the next 10 games, is going to equal 0.834701 to the power of 10. And that gives me 0.164. So again, if you're watching this and you're doing level 3, you can think about that as just a big tree, and you want all of the branches of the tree to give you at least 1 goal, right? So we've got 0.83 da 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 on these, and we're moving down that one path of the tree. You might want to think about how you could make that problem a bit harder for yourselves by saying in 5 of the next 10 games, right? What are the chances of getting at least 1? Because then I would have a binomial situation sitting on top of the basic Poisson. Okay, thanks for watching. If you're watching this from my 13 MAS class, if you could just let me know if it made sense and if you had any follow-up questions.